But sometimes, y is not just represented by one variable. So for example, family income is not just the factor to have a higher student grade. So we have other factors. So we have multiple x values, not just family income. So we call this the multiple regression. So in our case, we will have this formula. Y is equal to b1x1 for the first variable, plus b2x2 for the second variable, and of course, the constant. So let's solve multiple regression. Now let's say we want to predict the student's grade if they have this family income and if they have this sexual orientation, 0 for female and 1 for male. Now, to use Excel, we will again click data. So data, we click data, 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 and then we click data analysis. We will select regression again, and then we put the Y range. The Y range is this. This is something that you want to predict. If you have the family income and the sexual orientation. So select all of this. Again, you select female to family income. Okay? And then click check for labels, check for confidence level, and then select the new worksheet. And then click OK. And now you will have this. Now, we have our ANOVA, but we will discuss that soon. We will only focus in this part. The equation will look like this. Since you have two independent variables, you use b1x1 plus b2x2 plus constant a. So for us, that is y is equal to the income, the family income, x1 plus, I think they use the sex first, sex, and then the income, x2 plus the intercept. So we will use these values. So our equation is y is equal to negative 2.88 x1 plus 0.11, I round it off, x2 plus the intercept, which is 80.23. And this will be your final answer. But we will discuss later the p-value and the t-stat to know if it's significant or not. But that will be in our next topic.